G'day, welcome back. We are now on our second lesson for the week, so a Tuesday lesson in theory, and it's more about simple interest. This time we are looking at something, well, the text calls it simple interest as a recurrence relation, and that sounds quite intimidating. What it actually means is that if you have simple interest, the value of your investment or your debt each year is going to be, well, the previous year plus or minus a set amount. So if you invested $2,000 and you're getting $60 interest each year, the value each year is just going to be the last year plus 60. So if I'm making 60 bucks each year, if I start at 2,000, it would be 2,060, then 2,120, then 2,180, and so forward. All you need there is, well, the value next year is going to be the previous year plus 60. That's what it's about. Technically, the text will tell you that to be a recurrence relation, that you need to have an initial value at some point, so the initial amount invested, and there's a rule that says how you find each year after, which in my example there was, well, 1 year is going to be the previous year plus 60. Now, they have some formulas for this stuff. So written here, recurrence relationship, it's simple interest is a actually fairly simple recurrence relation, because each year your simple interest debt or investment is going to go up or down by the same amount. So there's formulas that they use for a recurrence relationship, and it looks like this. Vn plus 1 equals Vn plus D. Now, essentially this means the value next year, that's what the n's about. N is a given year, so the value at a given year, value this year, and D here is the amount that the value goes up or down each year. Right, so in my early example, let's say you had $2,000 and it was going up by $60 each year. Well, the value next year is going to be 2,060, right? So I start with 2,000. I'm going to make $60 this year. The value at the end is 2,060, right? But the terminology in the book can be a little bit awkward, but that's over to you guys. Look, here, the other thing that you need to note is sometimes you'll see V0. What that means is the value at time 0 at the start of your problem, which happens to be similar to another symbol we used the other day, and that was P. So wherever you see V0, meaning the original value, it essentially means P. It's the same as P from our previous lessons. The other thing I need to point out is a way of calculating D. D can be calculated by, what do we use? V0 divided by, I times, So D is I times P0. And you'll need to remember what on earth that means. What's little I? Remember that? I was the interest rate as a decimal. This strange theory that we're dealing with now is best shown by examples, and that's exactly where I'm going to take this in a moment. Just going to make sure I haven't left out anything really obvious to you. All right, so let's do this. Need some space. I wish I had a bigger whiteboard. Anyone got a bigger whiteboard handy? So you'll get questions that look a bit like this. I'm going to use different numbers and different values to the text so that you've got, again, separate examples in the text if you want to work with that. I'm going to go $5,200 is invested in a simple interest account for, we'll make it 5 years at 2.6% per annum. That's still more than you're going to get these days, sadly. And right, set up a recurrence relationship relation to find the value after any number of years. So they call it N, but it just means any number of years. So we're going to start off with that general formula again. There we go, I don't have to rub it off, that's nice. Right, so this formula here says the value in any given year is the value of the previous year plus this fixed amount. What you actually need to find out then is the fixed amount. What is D? How much is this investment going up by each year? I didn't give it a name, it needs a name. Oh well, too late now. Right, gave you before the idea that D is going to be I times V0, where V0 is simply the initial value. So if I look up here, the initial value is here, that's V0, and I've got there. Remember, this I is the, drop the lid, is the decimal value. That's a percentage. How do we turn a percentage into a decimal? Need to divide by 100. So I is going to be 2.6 divided by 100. So we put that into the formula, 2.6 over 100 times the initial value of 5,200. What do we need now? A beautiful, beautiful Casio scientific calculator. I've got 100 times 5,200. And it gives us 135.2. What that means is the value of this investment each year is going up by that amount. I really lost that pen. Right, so every year the investment increases by $135.20. Right? What was the original question? The original question said, set up a recurrence relation. That's your template for a recurrence relation. All we need to do is put the value of D in it and you've actually got the recurrence relation. So the value in any particular year is going to be the value of the last year plus $135.20. We may leave it as just 0.2 if we want. All right, then the sort of thing you're going to be asked is, well, find the value after 3 years. So part B of this is, what is the value after 3 years? At each point, you can find the value of a given year. It's going to be the previous year plus that amount. Really, I prefer to do this using linear relations. Everyone loves linear relations, don't you? Anyway, so forgetting that for a sec. So the value at year 1 is going to be the value initially plus 135.20. Remember, we found this is the value of this investment goes up by this each year. So the initial amount was 5,200 and it'll go up by $135.20. So the value at 1 year will be 5,335.20, and we continue that. At the second year, it'll be the first year again. The value at the first year plus another 135.20. So it's going to be 5, 4, 70, 40. The value at the third year then will be the value at the second plus another 135.20. So you get the idea? The value is just going up every year by the same amount. And that value, in this case, it's going up $135.20 each year. So each year to get the new value, you just add $135.20. So that there should be 5, 6, 05, 60, hopefully. Does anyone trust those numbers? It's going to be very embarrassing right now if it's not, because... oh, beautiful. Just used a bit of linear theory. I mean, really, the value after 3 years is going to be your initial value plus 3 times that. Think about it. All right, so that's the sort of stuff you need to be able to do. More annoyingly, you're going to have to be able to rearrange this formula and use it in different ways. So we'll show you that. Have to clear all this off. Got a good photo? Taking down good notes? Right. Now, in a previous lesson, I showed you how to rearrange the simple interest formula. We had I equals P IN, and we learned that we could rearrange that into 3 different forms. We could get P is I divided by IN. We could get I equals I divided by PN, and we could get N is I divided by PI. So you got those 3 different forms. And in this case, remember that V0 is exactly the same as P. So remember P is equal to V0. So you can rewrite each of these simply with V instead, V0 instead of P. And that's what the text does. All they do is give you those formulas again, except they've written V0 instead of P. So the ones you then see in the text look like this. V0 is I divided by IN. I equals I over V0N, and N equals I over V0I. All I've done there is swap the letter P for the expression V0, right? That's all that's been done. Nothing really impressive there. Nothing to write home about, I'm afraid. All right. From there, you could be asked a series of different looking questions, but similar sort of ideas. All right. So, this looks like one different to what we did last lesson, so this is good. I'm going to use different numbers, of course. I mean, this one says that a building society, a form of bank, is offering 8% simple interest. If you can find anyone offering that these days, I'd run a mile, as they're probably involved in illegal activity. Now, here we go. I don't know, maybe we'll give them a name. Cara. Cara offers 4.2% simple interest. That's still really high at the moment on an investment. Right. The investment earned 720 over 5 years. How much was initially invested? Okay, so what we'll do here is, well, what do we got? What do we want and what do we got? Let's look at the question. Boy. All right, so here we've got some form of interest rate. Remember that in these formulas we use a decimal. So I is going to be 4.2 divided by 100, turning the percentage into a decimal. We've got a number of years. The interest rate's in years. The time period is in years, so there's agreement. We're working in years. So we've got N is 5. We've got it earns this much interest. So that's big I, the amount of interest. I is 720. And what did we want? How much was initially invested? What symbol do we use for how much was initially invested? That's the principal. So you can use P or you can use VO. It doesn't really matter. P or VO, but we're using VO today, so I'll probably put that in. That's what we want to find out. We want to find out VO. We want to find it out from the other information. So with that at hand, our formula for VO, if we want to just VO, is this one here. VO is I divided by IN. We put in the values. Big I, the amount of interest, is 720. Little I is 4.2 over 100 times 5. We put that in our calculator. Maybe I could do it in my head with enough time, but we're not going to sit here and do that now. Or maybe we should. 100 times 5. Right, we're finding out that approximately 3,428.57 was, therefore, so we go answer it properly, $3,428.57 was invested initially. I'd personally be tempted to check something like that. You could go back and use this original formula and see if it makes sense. So if I was using this formula, P was 7, what was P? We're saying that's P here, 3,428, that's our initial value, times the interest rate, so 4.2 divided by 100, times number of time periods, which is 5. See, this is a nerve-wracking. This video is sort of going to be very embarrassing right now if I get this wrong. So I put in P, the same as V0 is the same as P. I've gone P times I times N, and it's going to give me the amount of interest. And I need it to give me about 720, or this will be a terrible example. It is. The only difference there is rounding error. It's saying 719.9997. That's what happens when you round, and we did have to do a little bit of rounding here when we calculated that. So that's okay. All right, there's another example where in the textbook that you can look at, which then asks you to find the yearly interest rate. So the yearly interest rate, which letter is it? Little I. So the second question, you need to frame your question like this. You'd find the amount of interest, the initial value, your number of years, put it in the formula, and hopefully you'll agree somewhat with what the text is saying. So there you go. That's lesson 2. Make sure to go on to the recommended exercises. If you've got any questions, send them along, and we may or may not make a video of this format. Cheers. Thank you.